doubt also. So then we'll move on to the next problem. So first problem is what we discussed so far. We discussed two problems. In those two, first problem is direct tensile load. The second problem is on direct tensile load as well as direct shear load. So now this problem is corresponding to the torsional load, and that is a torque. So first I'll read the problem, then we'll discuss how we can solve this problem. A shaft is transmitting 97.5 kilowatts at 180 rpm. If the allowable shear stress in the material is 60 MPa, find the suitable diameter for the shaft. The shaft is not to twist more than 1 degree in a length of 3 meters. Take C is equal to 80 GPa. C means here it is a shear modulus. So some books they will use G also. Sometimes they will use C. C or G, capital G, both are same. C or G, it stands for shear modulus. So what do you mean by shear modulus?
Yes, sir.
Mr. Raja, are you there? Unama?
Sir.
So shear modulus and the idea.
Yes, sir.
What do you mean by shear modulus? Yeah, response level. You know it or not?
Shear stress by shear strain, sir.
Who is that Raja or somebody else is answering it?
320, sir.
Okay, so but I asked me the Raja, na? Okay, no issue. So what is just like your Young's modulus? What is Young's modulus?
Stress by strain.
Normal stress. Simply don't say stress. That is wrong. So what kind of stress? Stress and shear stress avachchu, ingot stress kuda avachchu kada. You need to say normal stress divided by normal strain. We'll call it as Young's modulus. Similarly, shear stress divided by shear strain, we'll call it as shear modulus. So since this problem is related to the shear stresses, he has given the shear modulus. We require the shear modulus. And also here, this is a design problem. Like I said, there are two kinds of problems. One is analysis problem, another one is a design problem. Here, this one is a design problem. Why? Because he asked us find out what is the suitable diameter for the shaft. So that means we are estimating the size of the component. Means that is a design problem. Suppose if the sizes dimensions of the component is given and ask you calculate what is the stress, then we'll call it as a analysis problem. So that means in the analysis we will say whether the component is safe or not. That we can say. Whereas here we need to design the component for safe working. So we need to find the suitable diameter. Means it is a design problem. That's okay. That's up to that point. It's okay. But for that he has given two conditions. So we need to design our shaft such that the first condition is the allowable shear stress in the material is 60 MPa. So that means whatever may be the shear stress induced because of this power transmission. The shaft is used in the power transmission. It is transmitting a power of 97.5 kilowatts at a speed of 180 RPM. RPM means revolution per minute. So we'll call it as a angular speed. So while transmitting this power at the given speed, so the shear stress, that is the torsional shear stress, should not exceed the 60 MPa. That is the one condition. So that means you need to choose the diameter of the shaft such that when the particular shaft transmitting a power of this 97.5 kilowatts at 180 RPM, the stress should be less than, the torsional shear stress should be less than 60 MPa. That is one condition. And another condition what he has given is that the shaft is not to twist more than 1 degree in a length of 3 meters. So that means he has given the length of the shaft as 3 meters. So therefore the total twist in the shaft should be less than or equal to 1 degree. If the twist is more than 1 degree, then we can say the design is failed. The design is failed means the shaft is failed. So whatever diameter we choose, that diameter with the diameter, the twist in the shaft should be less than 1 degree. So these are the two conditions it has to satisfy. So I think like in the beginning classes I said one example while discussing about some design principles. So the shaft is designed and based on two criteria like I already mentioned or told at that point. So that's what is the same here he has given. So here if you design the shaft based on strength, so that is the first point here. So first condition is corresponding to the strength criteria, and the second condition, that is the shaft is not to twist more than 1 degree. That is based on the stiffness criteria. So that means now what we need to do is we need to design the shaft for two conditions. So first we'll take the strength condition, then we'll take stiffness conditions. So then we'll compare which one is the actual choice for the given application. So for that we know, so this is the power which is 97.5 kilowatts. So and the speed is something like 180 RPM. So now here I said, like I said, while transmitting the power, the shaft is subjected to torque. So I want to find out what is the torque the shaft is subjected to. So once I know that, then I can use the torsional equation, that is T by J is equal to tau S by R,
G theta by L.
which is equal to G theta by L. This is what we already discussed in the previous classes. So we'll use this, we will call this one as a torsional equation. So using this torsional equation, I can compute Ts, tau S. Tau S is nothing but the torsional shear stress. So from this I can write tau S as, what is the formula for tau S? So I need to bring this R to this side. So generally people use small r instead of capital R. I'll also use the same thing. T into R by J. So that means if I know the torque, if I know the, obviously the R is nothing but the distance from the centroid. So always the maximum, we already seen the earlier graph, the maximum shear stress will occur at the outer periphery. That means at the outer, at the diameter. So we need to take this one as diameter by 2, D by 2 as this one. And we know that J is nothing but the formula. So polar moment of inertia for a solid circular shaft, it is 5 by 32 into D power 4. So like I said, so these things, if you know these formulas, everything is okay, well and good. Otherwise, if you don't know what is the formula for J of a circular shaft, so if you don't know that, if you have a data book with you, then you can go through the data book. Then the data book, they will give this formula for you. Not only J, so they will use section properties for any section. What is the area? What is the centroid, position of centroid? What is the mass moment of inertia? What is the area moment of inertia? What is the polar moment of inertia? Like that, everything is available in your data book. That's why I said you need a data book, or it is essential for this course. Okay, right. So for time being, anyway, these are the formulas. So that means using this, I can calculate this tau S. But what is the tau S? It should be 60 MPa. It should be equal to 60 MPa only. So therefore, by equating this in this entire equation, I have only one unknown. So that is, first I'll calculate torque. T is nothing but, from the power equation, your formula for P is equal to 2 pi NT by 60. Power P is equal to 2 pi N into T by 60. This is the expression for power transmitted by a shaft. But I want here T, not P. So then what I can write is T is equal to 60 P divided by 2 pi N. 2 pi N, where this P is the power transmitted. So then I need to substitute this P in watts, not kilowatts. Even though he has given in kilowatts, we need to substitute in watts. Why we need to substitute in watts is again units. So I want to find what are the units for this. Suppose if I am choosing the diameter as dr, the stress value is 60 MPa we are taking. How allowable shear stress is 60 MPa, means what it is, 1 MPa is 1 Newton per mm square only. So therefore it is 60 Newton per mm square. So therefore whatever torque I am deriving here, the torque should be in mm and the force unit should be Newton. That means Generally, we have a torque unit as Newton meter or Newton mm. So now I need to get this torque in terms of Newton mm. So if I want to get the torque in Newton mm, what I need to do here is, what are the units for the kilowatt? Kilowatt means I can convert that one into watt, that is 10 cube watt. So what are the units for the watt? 1 Newton meter, we'll call it as watt. 1 Newton meter is watt. So therefore here you have a meter is there. So if you want to convert this one into Newton mm, what you need to do is, you need to multiply again on one more 10 power 3. That means 10 power 6. So that means I need to take 97.5 into 10 power 6, so that it will become, if you substitute into this, whatever units I got for the torque, it is going to be in Newton meter. So I know the torque, I know the R value, I know the J value. So then I equate this one to this 60 MPa. So from that I get the D. Only unknown in this entire equation. This is the design equation for us. In this equation, the only unknown is D only. So I can solve that D. I can find the solution. Okay. So that I will show it to you here. So first, the same thing what I explained to you, 97 kilowatts. Now he has written the given data. 97.5 kilowatts is converted into watts just by multiplying it 10 power 3. Then N is 180 RPM is given, tau is 60 Newton per mm square. So similarly, theta has given in 1 degree. The twist in the shaft is not more than 1 degree. So always we need to take the theta in radians, not in degrees. So to convert the degrees into radians, I need to multiply that one by pi by 180. Then I'll get this one as a radians. Of course, length is given 3 meters. So that is also converted into mm. And similarly, the shear modulus is 80 GPa. If we convert that one into MPa, it is 10 into 10 cube MPa, 80 into 10 cube MPa. 1 MPa is nothing but 1 Newton per mm square. Like that, he has written all the solutions. So now, first he calculate the torque. So for that, P, just now I told the expression, P is equal to 2 pi NT by 60. So whatever he got it, so here it is 10 cube only he has taken. So in that case, he got the Newton meter as the unit. So that means power is substituted in watts. So 1 Newton meter is the unit for the watt. So if you substitute the data here and if you compute it, the torque comes out as 5172 Newton meter. So then again, I need to convert this meter into mm. Just I need to multiply that one by 10 cube. So now I know the torque value. Then what I need to do is, I need to calculate what is the formula, or I need to write the design equation to compute the diameter of the shaft based on the strength. So considering the strength of the shaft, that's why he mentioned here also. So here, this is the torque which the shaft is transmitting. So it should be equal to, you can write the equation something like this also. So here he has written, the formula is T is equal to tau S into ZP, where the ZP is the polar section modulus. So whatever you have, J by R. So this can be written as something like this, ZP, polar section modulus. So if that is the case, so I already told you J is 5 by 32 D power 4. Then R is nothing but D by 2. So if you simplify that, you will get 5 by 16 into D cube. So that's what he has written, 5 by 16 into D cube into tau. So substitute the given data, 5 by 16, tau is given as 60, only unknown is D cube. So therefore, 5172 into 10 cube is equal to 11.78 into D cube you are going to get. If you solve this equation, from this you will get the diameter of the shaft as 76 mm. So that is the first part. So that means we design the shaft based on strength criteria. That means if I take the shaft diameter as 76 mm, the induced stress in the shaft is either it is equal to 60 MPa or it may be less than 60 MPa. But what about the other condition? The other condition what he has given is the angle of twist is not more than 1 degree. So now we need to check that condition also. That means we need to design for the stiffness. Now we need to design for the stiffness. So for that, again, this is the equation you need to use. T by J is equal to C theta by L or G theta by L. So theta is given, L is given, C is given, J is given, and Okay, of course, J is not given, and this T is also T is already calculated. So now we need to substitute all those parameters here. So for that, this is the T we already calculated here, 5172 into 10 cube divided by J, like I mentioned, 5 by 32 into D power 4. If we simplify that, we are going to get 0.0982 into D power 4. So it should be equal to C. C is nothing but 80 into 10 cube. We already seen that. Theta is given as 1 degree, but you need to convert that one into radians. So that just by multiplying pi by 180, I got a 0.0174 divided by L. L is nothing but 3000 already given. So now, if you simplify this equation, you are going to get something like this. From this, you can calculate diameter as D as 103 mm. Okay, so that means I designed the shaft based on two criteria. First criteria I have taken it as strength. The second criteria I have taken it as stiffness. Now I need to select my final dimension or final diameter for the shaft. So whether I have to choose. So for first with the strength criteria I got 76 mm as the diameter of the shaft. With the stiffness criteria I got 103 mm as the diameter. So now out of these two, which one value I need to select for the shaft such that both the conditions should satisfy. See now he has given the two conditions. Stress should not exceed 60 MPa and angle of twist should not exceed 1 degree. So based on the stress value I got 76 mm. Based on the angle of twist I got the diameter as 103 mm. Now you tell me out of these two which value I need to choose for the shaft. What is which diameter I need to choose for the shaft? Now you tell me. So first I'll ask your response, then I'll explain why you have to choose which value you need to choose. So now every time same instead of responding same person, now I will take some other one. So I'll ask Mr. Surya. So do you have any idea? So రెండు డయామీటర్లు వచ్చినాయమ్మా నాకు షాఫ్ట్ డిజైన్ చేస్తే ఒకటేమో స్ట్రెంత్ బేస్ మీద డిజైన్ చేస్తే 76 mm వచ్చింది. అట్లానే స్టిఫ్నెస్ బేస్ చేసుకొని డిజైన్ చేస్తే 103 mm వచ్చింది. సో మేబీ ఆన్సర్ కనిపిస్తుంది నీకు. ఓకే, సో దెన్ విచ్ వన్ ఐ నీడ్ టు చూస్? ఉన్నావా? మైక్ ఆన్ చేశాడు. నాకు వినిపిస్తలేదురా, నువ్వు మాట్లాడుతున్నావు లేదో నాకు అర్థం కావట్లా. ఐఎమ్ నాట్ ఏబుల్ టు హియర్ యూ, బట్ ఇట్ ఈస్ షోయింగ్ దట్ యువర్ మైక్ ఈజ్ ఆన్. Even I am not able to hear anything. So okay, right. So and then question అడిగినప్పుడు మనకి మైక్ ప్రాబ్లం వస్తుంది అంతేనా? Okay, leave it. So I'll go to the another person, maybe Shiv Prasad. Okay, I think he may not answer the question. Okay, Mr. 319 Chaitanya. Question అడిగినప్పుడు పాజిటివ్ రెస్పాన్స్ ఉంటుంది. Yeah, do you have idea which value we need to choose?
Low value, sir.
Lower value. So what is the reason for that?
లోయర్ వాల్యూ తీసుకుంటారని తెలుసు
కాబట్టి తీసుకోవాలి, స్మాలెస్ట్ కాబట్టి చూస్ చేసుకోవాలంటే అంతేనా? Okay, right. So okay, I'll come to I'll discuss the answer. Okay, so you switch off your mic, then I'll go to Uday Kalyan. Uday Kiran, not Uday Kalyan. Uday Kiran 25.
Sir, ఇప్పుడు మైక్ పని చేస్తుంది సార్.
మరి చెప్పగలవా ఆన్సర్ ఏమన్నా?
సార్ స్ట్రెంగ్త్ ఉంటే బెటర్ సార్ స్టిఫ్నెస్ కన్నా.
సో 73 ఉంది, 103 76 ఒక వాల్యూ, 103 1 వాల్యూ ఒకటి ఉంది. దాంట్లో నువ్వు 73 76 చూస్ చేసుకుంటా అంటావు
సార్.
రెండు డయామీటర్లు వచ్చినాయిరా. బేస్డ్ ఆన్ స్ట్రెంత్ వి గాట్ 76 mm. Based on stiffness criteria we got 103 mm. So which value we need to choose? Final రెండు వాల్యూస్ అయితే ఇవ్వలేదుగా. ఒక షాఫ్ట్ నువ్వు ఒకటే షాఫ్ట్ తయారు చేయాలి. సో ఒకటే షాఫ్ట్ డిజైన్ చేయాలి. ఒక షాఫ్ట్ కి ఏ డైమెన్షన్స్ తీసుకుంటావు నువ్వు? 76 mm తీసుకుంటావా లేకపోతే 103 mm తీసుకుంటావా? దట్ ఈస్ మై క్వశ్చన్. సో
సార్ 103 maximum తీసుకుంటాం.
why
Maximum.
why you have to choose maximum? So then you answer that also. You need to justify that also. Just simply రెండిట్లో అది మాక్సిమం కాబట్టి అది తీసుకుంటాను చెప్పడం కాదు కదా.
సార్ మనకి రిక్వైర్మెంట్ ని బట్టి తీసుకుంటాం సార్.
వాట్ ఈస్ ద రిక్వైర్మెంట్ ఆల్రెడీ వాడు ఇచ్చాడు కదా. 2 రిక్వైర్మెంట్స్ ఇచ్చాడు కదా నీకు. ఇంకేముంది? అదే కదా రిక్వైర్మెంట్ ఈస్ స్ట్రెస్ షుడ్ నాట్ ఎక్సీడ్ 60 MPa, యాంగిల్ ఆఫ్ ట్విస్ట్ షుడ్ నాట్ ఎక్సీడ్ 1 degree. దోస్ ఆర్ ద రిక్వైర్మెంట్స్.
స్టిఫ్నెస్ తీసుకుంటాం సార్ అప్పుడు.
ఎందుకు? వై యు ఆర్ చూసింగ్ స్టిఫ్నెస్?
1 degree కన్నా ఎక్కువ ఉండకూడదు అన్నారు కదా సార్.
ఎస్. ఇప్పుడు 76 తీసుకుంటే 1 degree కంటే ఎక్కువ ఉంటుందా?
అంటే అది స్ట్రెంత్ బేస్డ్ అన్నారు కానీ స్టిఫ్నెస్ అనలేదు కదా సార్. స్టిఫ్నెస్ కావాలంటే 103 తీసుకోవడమే బెటర్ సార్.
But you are not okay. So your answer may be correct, but you are not explaining properly. Okay, I'll come to that then. I'll go to one more person. Mr. 35. One more 20 after 25. It is Naveen. Oh, he is showing Abdul Kalam to me. Sorry. Okay.
సార్ చెప్పండి సార్.
Yeah. Do you have idea? Mani, idea ఉందా?
సార్ నాకు రీజన్ అయితే తెలియదు కానీ వచ్చిన దాంట్లో పెద్ద చూస్ చేసుకుంటాం అని తెలియదు.
వచ్చిన దాంట్లో పెద్ద చూస్ చేసుకోవాలి. రీజన్ అయితే తెలవదు. ఓకే, రైట్. సో బట్ ఆల్వేస్ ఇట్ ఈస్ నాట్ కరెక్ట్. సో మేబీ ఫర్ దిస్ ఇన్స్టెంట్ వాట్ ఎవర్ యు సెడ్ దట్ ఈస్ కరెక్ట్ ఓన్లీ. బట్ ఆల్వేస్ we need to choose the largest value is not the correct answer. Okay, right. So 48. నువ్వు చెప్పగలవమ్మా?
సార్
నీకు ఐడియా ఉందా రెండిట్లో ఏ వాల్యూ చూస్ చేసుకోవాలి, ఎందుకు చూస్ చేసుకోవాలి?
లార్జ్ వాల్యూ తీసుకోవాలి సార్.
రీజన్ ఫర్ దట్?
సార్
రీజన్ వై యు ఆర్
స్టిఫ్నెస్ కోసం సార్.
స్టిఫ్నెస్ కోసం యు ఆర్ చూసింగ్ లార్జ్ వాల్యూ. బట్ వాట్ అబౌట్ స్ట్రెంగ్త్? స్ట్రెంగ్త్ ఈజ్ నాట్ రిక్వైర్డ్. Okay, I'll move on.
103 స్టిఫ్నెస్ అండ్ స్ట్రెంత్ కండిషన్స్ ఎస్టిమేట్ తీసుకుంటాం సార్. సాటిస్ఫై చేస్తుంది.
103 will satisfy
ఎస్ సార్.
both the conditions.
అంటే 103 అయితే స్టిఫ్నెస్ అండ్ స్ట్రెంత్ కండిషన్స్ రెండు సాటిస్ఫై చేస్తుంది కనుక లార్జ్ వాల్యూ అది తీసుకుంటాం సార్. బోత్ సాటిస్ఫై చేస్తుంది.
Both satisfy చేయదా?
సార్
If I take 76 mm, is it satisfying both conditions or not?
నో సార్. 76 అయితే స్టిఫ్నెస్ సాటిస్ఫై చేయలేదు సార్.
Yes, right. That is the correct answer. Okay, right. Okay, so I'll move to the slide now. Like she said, 103 we need to choose 103 mm as a diameter for the shaft. Why? Because suppose if I take 76 mm here, so then what happened to the thickness, angle of twist? See here, your twist is going to increase, so more than 1. So if the diameter is 103 mm only, then the angle of twist is 1 degree. If the diameter decreases, what happened to the angle of twist? How we can say that here? See here, this is theta and this is j. So these two you need to relate the relation. If theta increases, what happened to, if d decreases, what happened to theta? You need to see that. So here, if d decreases, theta will increase. So from this relation you can see that, you can see here, theta and j, they are inversely proportional. So that means if diameter decreases, j will decrease. If j decreases, theta will increase. So that means, so 103, if the diameter comes below 103, then what happens here is the angle of twist will goes on increasing beyond 1 degree. So that means I cannot choose the diameter less than 103 mm. That is the main reason. So if I take 103 as a diameter, simply if I substitute diameter here, so here also tau and d, they are inversely proportional. If this is a constant, if tau increases, d will decrease, or if d increases, tau will decrease. So our criteria is it should be 60 only. So that means if I increase the d here, so then there is no issue. The stress is less than 60 only. If you take 103, we'll get the stress value less than 60. So that is also safe condition. If you take 103 mm as a diameter, even if theta is also less than 1 degree. Then, if not, if you take 76, so then your stress is 60 MPa, but your theta is going beyond 1 degree. So if you want, you can check that also. Here, in this equation, if you put theta is not theta, you calculate theta by just putting d is equal to 76 mm. You can calculate that. Definitely, it is more than this 0.0174 degree radians. So that's why what you need to do is you need to choose the largest of these two. So the largest value is 103. So therefore, the diameter of the shaft is 103 mm. So then maybe we'll round it off to the 105 mm. So based on the preferred number, whatever we discussed in the beginning classes, so we'll use if closest number to that size. So here we got from the calculation, we got it as 103 mm. But we'll round that one to the 105 mm. So or else in the examination you can leave the answer as 103 mm also, that is also fine. No issue. Nobody will question you. So if you know that, so then you can round it up to the nearest preferred number. So that is going to be 105 mm. So this is how you can solve the problem. Whenever there is a design criteria based on two things are there. So you have to first design for both the conditions. Then out of those two, which one is the better you need to select, or which one is satisfying both the conditions you need to select. Not better. Which one is satisfying both the conditions you need to select that one. So here this 103 mm diameter shaft will satisfy both the conditions. Whereas the 76 mm shaft will not satisfy the second condition. Therefore, we cannot choose 76. So that is the answer for that question. Okay. So next, this is the problem how we can derive when there is a shaft based on the two criteria. So then we'll move on to the another problem here. So previous problem is on twisting moment. Now this problem is on bending moment now. Okay, this is also, that means we need to make use of that bending equation. So whatever maybe you study in mechanics of solid course, m by, what is the bending equation? I think maybe I want to know from somebody else here.
M by I is equal to sigma by yi is equal
to m by I equal to
sigma by y is equal to E by R.
What are those things? M is
Moment of inertia.
M is moment of inertia.
Bending.
M is the applied bending moment. I is area moment of inertia. Sigma is the normal stress or bending stress. We'll call it as. Y is distance of the layer where you are calculating the bending stress. E is X modulus, and R is, what is R?
Radius.
Radius.
What radius?
Radius of the shaft.
Radius of the shaft. It is not radius of the shaft. It is the radius of curvature. Since your beam is bending, so there is some curvature in the beam. That radius of curvature is nothing but R. So that means here you have a straight beam, something like this. So now it is bending something like this. So therefore, whatever radius of this one, so this we'll call it as radius of curvature, R, not radius of the shaft, something like this. Okay. So anyway, that is not required in this problem because he has asked us only strength criteria here. We are going to discuss about strength criteria only. Okay. Anyway, so we'll see this problem also. So a pump lever rocking shaft as shown in the figure. So this is the shaft using some pump application. The pump lever exerts a force of 25 kN and 35 kN concentrated at 150 mm and 200 mm from the left and right hand bearings maybe respectively. So that means here a lever is there which is in a pump application. So this lever is supported on two bearings. Those two bearings are located, one is at A, another one is at B. So this is the symbol generally we'll use for the bearing. I think you are well known about this. In our CMDP course, you might have learned this designation of a mission elements also. We already seen that. So therefore, this symbol is for the bearing, right? Yes,
sir.
So this is the left bearing and this is the right bearing. It is supported here. So then it is subjected to 2 point forces, he said. One is 25 kilonewtons, other one is 35 kilonewtons, 150 mm distance from both ends. One is from 150, another one is from 200. That also he has given in the diagram here. So 25 kilonewtons is there, and from the left hand bearing it is at a distance of 150 mm, and another load of 35 kilonewtons is there, and this is acting at a distance of 200 mm from right hand bearing. So this is right hand bearing. So this distance is 200 meters. Then asked us at the center, find the diameter of central portion of the shaft if the stress is not to exceed 100 MPa. If the stress is not going to exceed 100 MPa, or in order to limit the stress value in the shaft or in the rod, whatever you can call it, or in the beam, to the 100 MPa, what should be the diameter at the center? So that is the question here. So here, even though it is looking something like this, so this is equivalent to your simply supported beam. So generally you have bearings here, that's what you have shown here in the diagram also. So this problem is somewhat, or this is equivalent to, I have a shaft which is simply supported at ends, then subjected to some 2-point forces. Here one force and here another force. So that is 25 kilonewtons, and here it is, you have 35 kilonewtons. So these distances also is given. So asked us calculate what is the diameter of the shaft at the center in order to, the stress induced in the shaft should not exceed 100 MPa. So even though he said you need to calculate the diameter of the shaft at the center, but is the diameter is changing from this end to this end? It is not changing here. See, it is a uniform shaft. The diameter is same throughout. So that means it need not be designed, the shaft should not be, need not be designed based on only the center. You can take any point, but only criteria to design the shaft is wherever there is a bending moment. So we know whenever a beam subjected to some point loads, it will subjected to a bending moment. Because of bending moment, there is a bending stress will be there. So that we need to compute. So that bending stress value should not exceed 100 MPa. Not only that, so there is not only bending stress, there is a transverse shear stress also there. So why you have a transverse shear stress? If you draw the shear force bending moment diagram. So I think you might have learned all these things in our previous course, that is MOS 1. You might have learned that. So if I draw the shear force bending moment diagram, it may be something like this. It will look like, and the shear force diagram will be something like this. So that means the shear force is not only zero at only here and at the ends. So in between you have a shear force also there. Because of the shear force, you have a transverse shear. We call it as a transverse shear. We know the formula for the transverse shear also. This tau is nothing but V. V is nothing but the magnitude of the shear force. V A y bar by I into B. So this is the formula to compute the transverse shear stress. I think you might have studied this. You take some standard sections. For rectangle section, how this transverse shear stress is going to vary. For I section, for L section, maybe for channel section. I don't know whether you have done for all those things. Maybe definitely you might have done it for the rectangle, circular, then I section and T section. Up to that point you might have done it. So using this formula. So here, so that means the shaft is subjected to two kinds of stress. One is, or else if we draw the bending moment diagram also, it is subjected to some, I can see that it is subjected to some bending moment also. But here, what we'll do is, to simplify the problem, we'll ignore the effect of the shear stress. We'll ignore the effect of torsional shear stress. That's why, okay, even though he has given it as 100 MPa, so we'll treat it as it is subjected to pure bending moment only. We'll assume it is subjected to pure bending. That means there is no shear force. The shear force is zero wherever the bending moment is maximum. That condition is valid even in this case also. If you draw the shear force and bending moment diagram for this, I'll show it here itself. So to draw the shear force bending moment diagram, first thing what we need to do is we need to calculate what are the support reactions. What is the magnitude of RA and what is the magnitude of RB. So by looking at this, I can easily directly write the value. But so this is the beginning class. So I'll tell you the procedure how we can calculate this. So one is you need to apply the equilibrium equations. In order to calculate this RA and RB, what you have to do is you need to apply the equilibrium equations. What are those equilibrium equations? Force equilibrium, that is sigma Fy equal to 0. So that means the algebraic sum of the forces acting in the vertical direction is 0. Why I consider only Fy? Because there are no forces acting in the horizontal direction. That's why I am not consider sigma Fx is equal to 0. If horizontal forces are also there, I will consider this equation also, sigma Fx is equal to 0. But in this case, there is no force acting in the horizontal direction. Only I have two reactions, RA, RB, they are acting in the upward direction. And two applied forces, 25 kilonewtons and 35 kilonewtons, they are acting vertically downward. So that's why I will use this equation. So if I write this, so then what is the sign convention I will follow is, I will take upward sign or upward direction as positive. I will follow, if the force is acting in upward, I will take it as positive. Then obviously if the force in downward direction means it is negative. So now if I apply this, what I will get? I have two upward forces, that is RA plus RB. Then I have two downward forces, that is minus 25 and minus 35. So this is my one equilibrium equation. RA plus RB minus 25 minus 35. Why I have to take minus here? Because these two are acting in downward direction. Downward will consider as negative, upward as positive. That's why we were taking that. So now, if I simplify this, what I'll get is RA plus RB equal to, I'll bring these two to the other side. So which is 60 kilonewtons. 25 plus 35 is 60 kilonewtons. This is one equation. But I cannot solve one equation. I cannot solve two unknowns. RA, RB, both are unknowns. So I cannot solve two unknowns with one equation. I require one more equation. So how I will get that another equation? So by applying force equation, I won't get any another equation because there is no horizontal force. So I won't get the second equation for this sigma Fx is equal to 0. So if I consider force equilibrium, I will get only one equation. Then I will get that additional equation just by considering the moment equilibrium. So that means I can take moment about any point in the beam. So that is our choice. But as for our convenience, we'll choose A as a reference. So that means I'll write the equation sigma MA, that is algebraic sum of the moments about A should be equal to 0. Again here we'll follow sign convention. If the moment is in clockwise direction, we'll take it as negative. And if the movement is in anti-clockwise direction, we'll take it as positive. So you need not follow this one. This is what I prefer. But if you want to take in opposite direction also, no issue. It doesn't matter. It is not going to influence your solution also. That means clockwise positive, anti-clockwise negative, you take it. No issue with that also. So even with that also, you are going to get the same thing. So, but I'll follow this convention. Anti-clockwise is positive, clockwise is negative. So, if for that, first we need to write the equation now. Okay. So now, first you need to identify how many forces are there, and you need to identify what is the moment of all those forces. So in our problem, how many forces are there? RA, RB, and then 25 kilonewtons and 35 kilonewtons also there. There are total 4 forces are there. So you need to first find out what is the magnitude of movement because of those forces, and then you need to identify the direction also, whether it is anti-clockwise or clockwise. Like I said, anti-clockwise I will take it as positive, clockwise I will take it as negative. Okay, right. So for that, this implies, so this equation implies, so that means I am taking moments about this point. So recall definition for the moment. Moment is nothing but force into perpendicular distance. So that means I need to take the force, then I need to measure the perpendicular distance to the line of action of the force to the point where you are calculating the moment. So now here I am calculating moments about A. So that means my reference point is A now. So for all forces I need to calculate the moment about point A. First if I take RA, so then what happens here is the magnitude I don't know, but still I'll write the equation it as in terms of unknown value RA into what is its perpendicular distance from point A? It is 0 because I am taking the A itself as a reference. The distance is going to be 0. It doesn't matter whether you are taking a positive sign or negative sign because it is a negative quantity. Then I'll consider this 25 kilonewtons. So force is 25 kilonewtons. And what is the perpendicular distance between A and C? Here he has given the distance as 150 mm. 150 mm. So I'll take in mm only. So everything you need to take. So don't take one is meters, other one is mm. So if it is every dimension, if it is mm, you are taken for one thing, you have to take in mm for all the dimensions. Right. So now it is positive or negative. If I take movement about this point, so this force will create a clockwise movement for me. So I'll take it as negative. Then what is the movement of this force now? It is 35 into. Then what is the distance of the point B from point A? This is the total distance. So from here to here it is 150 and from C to D it is 600. So therefore it is 750. Even this is also generate a clockwise movement about point A in this direction. The movement will be in this direction. So therefore I need to take that one is also negative. Then I will have to with only RB. So I'll take RB into, then what is the distance, perpendicular distance between point A and B, line of action of this RB from here to here, this total distance. So here up to here it is 750, then plus 200 it is 950. It should be equal to 0. Of course, before that I need to identify what is the sign for this. So if I take moment of this RB about point A, it is creating moment. It is creating moment in anti-clockwise direction. So I have to take plus sign here. So anyway, I can cancel out this because it is 0. Then only left with is if I simplify this equation, what I'll get is I'll get an expression for RB. RB equal to, so these two, if I bring to the other side of the equation, they will become positive. Then divided by 950, I'll get the RB value. Once I got the RB value, so I'll get RB here in kilonewtons only. Why? Because I'll get in kilonewtons. Here I consider the load in kilonewtons only. 35 and 25 both are in kilonewtons only. So therefore RB, whatever RB I got it is, I'll get in kilonewtons only. I'll take this RB and I'll substitute into this equation. So then I'll get the RA value. Once I know RA and RB, then I can solve for, or I can draw the bending moment and shear force diagrams also. So I'll show you that calculation in the next slide. Okay, so here the same equation, whatever we written, he has done the same thing here. So just now whatever we written, RB into 950 is equal to 35 into 750, 25 into 150, which is 30,000. So if you simplify this, you'll get 30,000. From that RB, we got it as 31.58 kilonewtons. So that can be converted into newtons just by multiplying 10 cube. Then from the 60, if you subtract this 31.58, you will get RA as 28.42 kilonewtons. So that means we got RA and RB. So let us say one is 31.58 kilonewtons, another one is 28.42 kilonewtons. So now I am in a position to draw the shear force diagram for this beam now. So now if I take something like this, here itself I can draw it. So this is the load line. This is the load line here. So now if I take this one as a reference, so here it is acting upward. So I'll draw upward direction. So whose magnitude is, what is the RA we are getting? RA we got getting some 24 something, around some 24. So then between these 2 points there is no other force, so I need to draw a horizontal line. Then here you have a 25 means you will get a little bit something like this. Then it will move like this and it will go further down because of 35 kilonewtons. So then like this. So this is going to be your SFD. So once you got the SFD, so now only at this instant and at this instant and at this instant, the shear force is 0. So that means at point A, at point C, at point D, at point B, only bending moment, shear force is 0. So that means now, like I mentioned earlier, there is a transverse shear stress if the shear force is not 0. I already written the formula also. Tau is equal to V AY bar by I into T or I into B or T, whatever you can take it, I into T, where in this expression V is the shear force. If the shear force is 0, your shear stress is 0. That condition, what we call it as a pure bending. Pure bending means there is no shear, transverse shear. So then in that case, you can use this formula M by I is equal to sigma by Y. So this formula to compute the bending stress. So that means, so I cannot apply that formula to some other location here. See here, the shear force is not 0. So I cannot apply this formula to this location. So I can apply it for only the location where the shear force is 0. So that means I need to compute what is the bending moment at C, at D. Of course, the bending moment at B and A, they are 0 only. At A and B, they are 0 only. So therefore, I need to compute the bending moment at C and D. Then, based on at what point you have a maximum bending moment, that is, let us say if I assume bending moment at C is MC and bending moment at D is MD. Out of these two, I need to choose the largest value for the design. So if MD is more than MC, I'll take MD value for the design. If MC is more than MD, I'll take MC for the design criteria. Okay, so how we can calculate MD here? The bending moment is nothing but this RB into 200, you will get MD. Similarly, if you want to calculate MC, RA into this 150, you will get your MC value. So once you know that, then based on that, you can design the shaft. So that those calculations he has given. So first he calculated bending moment at D, MD, RB into 200. He got this much is the bending moment. Similarly, bending moment at C is RA into 150. He got this one. So out of these two, the bending moment at point D is maximum. So therefore, you need to choose this one as the criteria for our design criteria for our shaft. So then, with this bending moment, we need to use that formula. That is M by I is equal to sigma by Y. So sigma he has given it as 100 mm, 100 MPa. Sorry, not mm, 100 MPa. Then the other thing what you can do is you need to substitute all those things into the formula. Then you need to calculate. So I is unknown for us because we don't know the diameter. I formula is 5 by 64 into D. For a solid circular shaft, that is 5 by 64 into D power 4. And Y is nothing but we need to take the maximum stress condition. Y is nothing but again here also it is D by 2. So this is the equation. We'll use this equation to solve that. So or else it is written in another form of section modulus. Your section modulus is nothing but I by Y. I by Y max. I can say not simply Y. I will say I by Y max is your section modulus Z. So I is 5 by 64 D power 4 divided by D by 2, you will get 5 by 32 into D cube only. So once you know the section modulus, then you can easily calculate what is the bending stress also. So the formula for bending moment is M is equal to sigma into Z. So same thing. So why I got sigma into Z? Just now we written bending equation M by I is equal to sigma by Y. So if I bring I to this side, so then it become sigma M is equal to sigma into I by Y. It become M is equal to sigma into I by Y. So, but what is I by Y? I by Y is nothing but, I'll write this I by Y as Z, section modulus. So therefore, our M is equal to sigma into Z. but I want to calculate sigma. Sigma is nothing but only m by z. So sigma is given as 100. M we already calculated as 6.316 into 10 power 6 Newton mm. So z is only unknown, and that is in terms of d only. So then by this one is our design equation. By solving this equation, design equation, we will get the diameter of the shaft. So from this, the diameter of shaft comes out as, if you solve this, we get d is equal to 86.3 mm, which is rounded off to the 90 mm. So that is the answer for the problem. Is it clear or any doubt in this? So I think we discussed two problems now. One is on torsional torque are shaft subjected to torque. Another problem we discussed about torques are subjected to bending moment. So I think next class is also our class only, that is a discussion class. So we'll extend this. So if you have any doubt, then we'll discuss. In the same manner, we'll extend this class also. Somebody has written a Venkatramana Dutt. Section module. What is section module? It's not section module, it is section modulus. Is that is your doubt? And also somebody is written Srikanth 950 plus. I don't know what is this 950 plus. ఏంటమ్మా నువ్వేంటి నాకు అర్థం కాల సెక్షన్ మాడ్యూల్ అంటే ఏంటి వాట్ యు వాంట్ టు ఆస్క్ ఐ డిడ్ంట్ గెట్ యువర్ క్వశ్చన్ యు సెడ్ ఐ రిటన్ ఓన్లీ సమ్ సెక్షన్ మాడ్యూల్
మీరు ఇందాక అడిగితే చెప్పాను సార్ దానికి
ఓకే రైట్ సో ఇట్స్ నాట్ సెక్షన్ మాడ్యూల్ సెక్షన్ మాడ్యులస్ ఓకే రైట్ సో నా వాయిస్ సరిగ్గా లేదా మీకు వినపడలేదా సౌండ్ లోగా వస్తుంది సార్ అంటే ఓకే శివప్రసాద్ ఈజ్ ఇట్ నాట్ ఆడిబుల్ ఫర్ ఆల్ ఆఫ్ యూ
వినపడుతుంది సార్ అంటే ఫోన్ వచ్చి సౌండ్ తగ్గిపోయింది సార్ ఇప్పుడు వస్తుంది
నీకు ఫోన్ వస్తే మరి నాకు అట్లా వస్తుంది ఆ ఫోన్ వస్తే ఆటోమేటిక్ డిస్కనెక్ట్ కూడా అవుతుంది దానికి మనం చేయగలిగింది ఏం లేదు
అదే సార్ పని చేస్తుంది సార్ ఇప్పుడు
అయితే ఓకే మరి ఇప్పుడు అంత అర్థమైందా నీకు రెండు ప్రాబ్లమ్స్ క్లియర్ గా
ఎస్ సార్
సో అసైన్మెంట్ ఇస్తే సాల్వ్ చేస్తాం మరి దీని మీద
ట్రై చేస్తాం
ట్రై చేస్తా అంటే నాకు డౌట్ వచ్చింది మళ్ళీ నువ్వు అర్థం కాలేదనిపిస్తుంది నాకు
ప్రాక్టీస్ చేయాలి కొంచెం ప్రాక్టీస్
for the practice purpose only I am giving the assignment.
Yes sir.
Okay, so maybe I'll put after some time in the classroom, Google Classroom itself, you might have try some problems so that you will familiar with that. So okay, right. So any other doubt? Your kind doubts on any doubts unte then you can ask. These two problems. So లేదంటే we'll take up one more problem and then we'll conclude the class. I think only 54 members. Some people are already left out. So second class is also ours only now. ఓకే, నా దగ్గర పవర్ ప్రాబ్లం వచ్చింది, పవర్ పోయింది, ఇప్పుడే వచ్చింది. మేబీ దోస్ ఆల్రెడీ లెఫ్ట్ ద క్లాస్ నా, జస్ట్ ఇన్ఫార్మ్ దెమ్ టు జాయిన్ అగైన్. I'll take the I'll send the attendance sheet for the next class also. Just respond for that also. I think you are hearing to me. You are able to hear me, right?
Yes, sir.
All right.
Yes,
So,
sir.
Okay, right. So just now I'll put that sheet. Just respond for that. So take 5 minutes. Then we'll discuss the doubts. If no doubts are there, I'll discuss one more problem. Then we'll close the class. Now 4:20. Now you can check. You'll receive that attendance. Just fill that attendance. Then we'll discuss about the doubts. So some more need to respond to the attendance sheet for this class now, for second class. Okay, I think all of you done that. Maybe still some more. Here it is showing 57. 57 minus 2 means 55 people are there online, but here it is showing only 52. 5 more. So in this 5 more need to respond. Okay, what I'll do is I'll stop the recording.